Hello, welcome to another class of Tutopia. This is Shemonti Dev and I will be teaching physics to you all guys. So today we'll study a very important yet very interesting topic of physics, that is light. When I say light, what is the first thing that comes to your mind? That light is a ray, it is a source of energy, okay. So, we all think or consider light as a source of energy, that when it falls on a surface, we are able to see that object or a surface. Before that, let me tell you what an object is. Everything around us is an object and we are able to see everything, right, which are around us when there is light, provided when there is light. If I stand in a dark room, you guys won't be able to see it. You are able to see me now, right, because there are all these lights around. We are only able to see an object when there is light present. So this brings us to the concept of object and image. So what is an object? An object is something that exists in the real world, okay. An image is a replica or a copy of the object that is created when light falls on it. A very simple example is a photographic image, or we can see everything, we are able to see everything around us because an image of those objects are created in our eyes. Now, how an image is created in our eyes is a part of a very interesting phenomena of light, that is refraction, which we will study later. Now, let us see how light is perceived through different sources. For example, for light to reach a source, we need a medium. Do we need a medium to for light to reach a source? No, light can travel through vacuum. Light does not need any medium for its travel, okay. Sound needs medium, okay, but light do not. The biggest example is the sun and our earth. Here is a sun and a few billion kilometers away, here is our earth. Between the sun and the earth there is just empty space and nothing else. So how do light travels from so many kilometers away to the earth? Because it does not require any kind of medium, light can travel without a medium. Now let us talk about the nature of light. Some say light is a ray of particles. Some say the light is wave in nature, and there are also claims that light has a duality in their nature. That duality is called wave particle duality. There is also a duality whether light is a wave or a particle or a stream of particles. Which? So these are for our higher studies. Now let us see how light works in our real world here and how we are able to perceive objects and images. Let us see what an image is. Now foremostly we can divide image into two categories. One is a real image, another one is a virtual image. What is real image? Any kind of image that are formed which can be obtained on a screen, like a projector. When we project a scene or a video on a screen, we are able to see it, right? But that is not a real object, that is just the projection of the video. So all the images that can be obtained on a screen are called real images or are real in nature. And the next category is virtual images. What are virtual images? Virtual images cannot be obtained on a screen. And a very nice example of virtual image is when you stand in front of the mirror, you see your copy, your image. That is a virtual image which cannot be obtained on a screen. Now, in the context of real and virtual image, there are further two categories that needs to be discussed, like erect and inverted. Real images are, the word inverted is always associated with real images, whereas virtual images are always erect. That means if you place this pen or anything in front of a mirror, would the reflection be inverted? No, the reflection would be as it is, as the object is, not the inverted one. So, for real images are always inverted. That is why if you put a spoon in front of your face, you will see that your image on the spoon is a reflecting surface, right? You will see your image on a spoon. If you see a spoon in front of you, then the image formed on the spoon will be inverted. Try this experiment and let me know. Okay, so these are two categories of images, real and inverted. Now we can also divide them into two more things, that is symmetrical and asymmetrical images. Now what is symmetric images? Let's see. Symmetric images can be formed when the object is symmetric, like the letter A. If you put a mirror in front of A, the image of A will be as it is. But if you put a mirror in front of the letter B, this will get inverted. This is the reason why the word ambulance written in front of, in the bonnet of every ambulance is written in an inverted way, because whenever there is a car or a vehicle in front of the ambulance, they will see the word written in a mirror, so that they get a mirror image, and the mirror image will be inverted. That is why the ambulance letter, all the letters of the ambulance in the entire word is written in a inverted way. This brings us to the concept of reflection of light. Imagine a cricket pitch. Here, this is a cricket pitch. If a ball, when the bowler bowls, the ball will first hit the ground and then will go straight to the batsman, right? So, this is the path a light also follows, just light travels in a straight line rather than this curved path. Imagine this to be a surface. In a similar way, how a ball bounces off from a ground, in the similar way, light also bounces off the surface it falls on. When the light falls on a surface, it bounces off. Suppose there is no surface here, then where will the ray of light go? The ray of light will straight travel through this path. It would have traveled through that path if the surface wouldn't have been present here. But in the presence of an object or reflecting surface, this is the source of light. Due to the presence of this reflecting surface, light reflects in this point and it's bounced off. Okay. So, now let's see how, if this is a ball, So, from how much elevation does the ball bounces off the ground? This will be our angle of elevation. Okay. Now, the angle on which the light is reflected upon is called the incident upon is called the angle of incidence. We draw a imaginary normal or a perpendicular to the surface at the point of incidence. Why are we drawing this normal, or what is the purpose of this perpendicular to be present? To understand whether this surface is straight to the horizon or it makes an angle with the horizon, whether it is tilted or it is straight. To understand this, we will draw an imaginary line which is called the normal. This will be at 90 degrees to the surface at the point of incidence. Now, the angle this incidence ray makes with the normal is called incident angle. When the ray of light is reflected through this point, this ray is called reflected ray, and the angle that it makes with the normal is called angle of reflection. Okay. Now, if there wouldn't be the surface present, the light would have been travelled through this path, but it does not. So, it deviates from this path to this path because of the presence of this reflecting surface. This deviated angle is called angle of deviation or D. So, this brings us to the reflection of light through a plane mirror. How a plane mirror works. This is how plane mirror works, or a plane surface of a mirror, or a plane, simply a plane reflecting surface. We have a source of light here, then there is this incident ray. It falls on the point of incidence. It was about to travel through its straight line if the surface wouldn't have been present, but due to the reflecting surface, from the point of incident it gets reflected away in this direction, making an angle R with the normal drawn on the point of incidence. So, here there are few things to be discussed about these angles of reflection. The first thing is this angle of incidence and angle of reflection are always equal. This is our first law of reflection. Next thing is, a straight line is always 180 degree. This is the normal to this straight line. So, this angle is also a perpendicular angle, that is 90 degree. So, this angle of elevation and angle of incidence, what do they make? They add up to 90 degrees. For the angle of deviation, light travels in a straight line. Straight line has 180 degrees. So, we will see that for angle of incidence plus angle of reflection plus the angle of deviation makes 180 degrees. Hence, angle of deviation can be written as 180 minus angle of incidence plus angle of reflection. This is the first law of reflection summed up. Now, here is a mirror. If a light travels in a perpendicular direction, then what happens? If a ray of light, here is a source of light, let me name it S. If a ray of light travels in this direction, then what happens? What will happen to the normal? What will happen to the reflected ray? Whenever light travels in a straight line in a perpendicular in 90 degrees to the surface, the light is reflected straight back through the same path. So, our incident angle is 0, so is our reflected angle or angle of reflection. So, can you tell me that what will happen to the angle of deviation? You might assume that angle of deviation would also be 0. But no, angle of deviation wouldn't be 0, because in mathematical term, if you see, if you put both 0 in place of I and R, you will see that angle of deviation is 180 degrees. But to physically perceive it, the angle of deviation will be 180 degree, because even though the light is travelling in a straight line, it was supposed to travel in straight line on the other side of the mirror as well, if this mirror wouldn't have been present. If suppose this mirror is not present, in this case what would happen? The light will travel like this. So this was the original path for the ray of light to travel, but due to the presence of the mirror here, it gets reflected back in the same path. This is our angle of deviation, that is 180 degree. So whenever light travels in a straight path through a mirror, our angle of deviation is 180 degree, and the incident angle and the reflected angle both are 0 degrees. This is how a plane surface or a plane reflecting surface like a mirror or a plane shiny metal, anything that is capable of reflection of light works, and these are the mathematical forms and the first law concerned with the reflection through a plane mirror or in general reflection. Now what happens is, this brings us to the second law of reflection. What is the second law of reflection? The second law of reflection says that the incident ray, this is our incident ray, this is our point of incidence, this is our normal, this is our reflected ray, this is the ray, traced ray, where this light was actually about to pass through. This is our normal, these are our angles. This is incident ray, this is our reflected ray. Now what happens? The second law says that the incident ray, the reflected ray and the normal all lie on a same plane. If you imagine a piece of paper, then what will happen? If the incident ray follows the plane of the paper, like it follows the plane of this board, the reflected ray will also be on this board and the normal will also be on this board at the point of incidence. This is our second law of reflection, that all these lie in a same plane. It would never happen that a light source coming from here, the point of incidence is here, will travel through this path. This case wouldn't be happening. A light ray will follow this path only if it travelled through this plane. While concerning light with other phenomena, there is reflection of light, then there is refraction of light, there is dispersion, diffraction, interference, and a lot of phenomena concerned with this chapter. Now, we all know that light travels in a straight path. If we put an object in front of us, it will cast a shadow behind the object. But it so happens that when the obstacle is very small or tiny compared to the source of light, the light ray that comes from the source bends through the edge of the object and reaches the screen or whatever there is behind the object. What happens is, this bending of light is called diffraction, which are for the higher studies. In this chapter, there is mainly reflection through different types of surfaces. Like plane mirrors we have already studied, there are spherical mirrors, then there are lenses as well. Reflection and refraction through lenses. Now, what we see is reflection through plane mirror. You can say what kinds of questions are we going to face in this regard. From this chapter, there are very common sorts of questions that come in the exam. Like, a few are these theoretical type of questions, like if you place the object here, where will be the image formed? Now, the concept of image and object and their distances between them we will learn in the later class. Then a few practical based questions, implementation based questions will be there, like how rainbows are formed. Rainbows are concerned with the sole phenomena of light, that is called dispersion of light. This is also another reason we see our sky is blue. The sky is not blue, there is no layer or covering around that is blue. We just see the sky as blue. Why do we see the sky as blue? This can be explained with another phenomena called dispersion. But for now let's focus on reflection of light.